Hello and welcome to this tutorial. In this video, I'm going to be going over how we solve systems of equations using elimination, specifically when we need to multiply an equation so we can then cancel out a variable and use elimination. So elimination is not a new method of solving systems of equations for us. We're just going to be taking it now to the next level with some different types of equations. Here's an example though of systems of equations that we have used in the past. This is what we know so far about elimination. So what we did is we were given two equations and we added them together, and when we added them, one of the variables needs to cancel. So in this case, our opposites that we have are negative 3x and positive 3x. So when we add them, they cancel. Everything else adds, we solve and get y is negative 1. Then we substitute that back into one of the original equations, solve this, and eventually get that x is equal to 2. So y is negative 1, x is 2. So this is what we know so far about elimination. Now is when the equations are going to start to look a little bit different. So sometimes we don't from the start have variables that cancel out. Like in that last example that I quick showed you, we had the negative 3x and positive 3x. So right away from the start, we had a variable that canceled, and so we could just add it how it was. Not always are the equations going to be so nicely canceled. So in that case, we're going to have to multiply one or more of the equations to create opposites, similar to how we multiplied an equation by negative 1 in the past. So taking a look at these examples, so the first one here, 6x minus 2y equals 10, negative 3x plus 7y equals negative 17. So using elimination, one of the variables should cancel, so either the x's or the y's. Well, looking here, positive 6, negative 3, that doesn't cancel. Negative 2, positive 7, that does not cancel either. So what we need to do is create an opposite by multiplying. So we'll see if we have any numbers that we can multiply to equal another number. What I mean by that is I'm noticing here we have a 3, and all I would need to do is multiply it by 2 to get 6. And then they should be opposites as well. This one is negative, this one is positive. So if I were to show you what I mean by this, if I were to multiply this negative 3 times 2, it would get us negative 6x. And if we had negative 6 here, then it would cancel with positive 6. So we needed to multiply this by 2 to create an opposite. But because it's an equation, if we multiply this by 2, we have to multiply everything in the equation by 2. So continuing on from here, positive 7y times 2, positive 14y, negative 17 times 2, negative 34. So now at this point, we are done with this one, so I'll cross it off. Then we add it and solve it just like normal now, because now we have opposites that cancel. Negative 2y, positive 14y, 12y, positive 10 plus negative 34, negative 24. Divide, y is negative 2. Okay, so then in an effort to save some time, since once we get to this point, the method of how we solve this, the process, nothing is different than what we've been doing before. So I just went ahead and solved this. I got y is negative 2, put this in for y in my one of my original equations. Doesn't matter which one I use, I just picked the first one. So then we had negative 2 times negative 2 is positive 4. I solved this two-step equation to get x is 1. Our solution is 1 comma negative 2. Now let's take a look at this next example over here. Our first step is to see if we have variables that cancel from the start. Positive 5x, positive 2x, nope, don't cancel. Positive 6y, positive 3y, nope, don't cancel. So that means we need to create our opposites that will cancel. So again, let's check to see if we have a number that can multiply to equal a number in another equation. So 5 times something equals 2, no. 2 times something equals 5, no. 6 times something equals 3, no. 3 times something equals 6, yes. 3 times 2 equals 6. So we can multiply this by 2, but the thing is here, these are both positive. So if we were to multiply this positive 3y times 2, that would get us a positive 6y, which still does not cancel with this positive 6y here. So we can't just multiply it by 2 this time. This time we need to multiply everything times negative 2, because, let me erase this here, if we have now negative 2 times positive 3y, that gets us negative 6y, and now this positive 6y, negative 6y will cancel. So then, just like in the problem before, if we multiply this times negative 2, we need to multiply the entire equation by negative 2. So I'll have negative 4x equals negative 5 times negative 2, positive 10. So done with this one. And then I'll just go ahead and add these two equations. Positive 5 plus negative 4 is positive 1x. Positive 6 at y minus 6y cancel. Negative 8 plus 10 is 2. So x equals 2. Okay, so then again, I went ahead and finished solving this system of equations here by substituting. Now, if I know x is 2, I put it into my equation. Either one is fine. I just picked the first one. And solve this to get that y equals negative 3. So my solution is 2 comma negative 3. All right, so finally we have two more examples. And we're going to follow through the same process as the earlier ones. So first, check to see if we have opposites. Negative 5, positive 2, nope. Positive 3, positive 5, nope. Then let's check to see if we can multiply by any number to equal another number to create an opposite. Negative 5 times something is 2, no. 2 times something is negative 5, no. 3 times something is 5, no. 5 times something is 3, no. So in this case, we're not going to be able to just multiply one of these equations by a number. We need to multiply both equations to create a common multiple that will cancel. So what we do in this situation is we take either the x's or the y's and we multiply each equation by the coefficient in the other example. So what I mean by that is, like here we have a negative 5x. So I'm going to be multiplying, if I have a 5 here, I'm going to multiply this other equation. I will multiply it times 5. Here the coefficient is 2, so I multiply my other equation by 2. So going through this work, negative 5 times 2 is negative 10x. Positive 3y times 2, positive 6y. Negative 6 times 2, negative 12. So there's the first equation. The second one, positive 2x times 5, positive 10x, positive 5y times positive 5, positive 25y. Negative 10 times 5, negative 50. So notice how when I multiplied the equations, I already noticed that I had an opposite here. This one was negative, this one was positive. So I didn't multiply by negative 5, because if I had multiplied by negative 5, that would have given me negative 10, and they wouldn't have canceled. So if it's already one is negative and one is positive, just multiply them both by the positive version of these. So let me erase this since we aren't really working with negative. And then we can go ahead and solve this now. We can add them up because now we have opposites that cancel. Positive 6, positive 25, adds to positive 31, negative 12 plus negative 50, negative 62. So y equals negative 2. Okay, so again, I finished up solving this problem off camera. So I substituted y for negative 2. Solve this equation to get x equals 0 for our solution 0, negative 2. All right, last example. We'll start to see if we have opposites. Positive 4, positive 3, no. Positive 2, positive 3, no. So then we'll see, can we multiply anything to equal another number? 4 times something is 3, no. 3 times something is 4, no. 2 times something is 3, no. 3 times something is 2, no. So then what we're going to do is multiply both equations to create a common multiple. So we could either work with the x's, multiplying this equation by 4, this one by 3, or you could work with the y's, creating opposites here, multiplying this equation by 2, this equation by 3. It doesn't matter which one we pick. I'm just going to randomly pick to cancel out the x's in this equation. So I'm going to multiply by the other coefficient, meaning if I have, for my x's, if up here we have a 4, we'll multiply by 4. And down here we have a 3, so we'll multiply by 3 up here. However, what I'm noticing is that both of these coefficients, the 4 and the 3, are positive. So if we multiply them both by positive numbers, we'll get positive 12x and positive 12x, which will not cancel. In order for them to cancel, we need one of them to be negative and the other needs to be positive. So either the 3 or the 4, it doesn't matter which one, just make it negative. Because now when we multiply, one will be negative and the other will be positive. So then I'll continue with my multiplying of my equations. And now we have opposites here. So when we add them, they will cancel. And then the rest of the process is the same. Again, I just finished up my work off camera. Something I forgot to note on this example here is when you substitute the number that you find for your first variable into the equation, you can pick any one of these 4 equations to substitute. In the end, it's going to get you the same thing since all of these are equivalent, so it will get you the same answer for x. I just randomly, pretty much I always just go with the first one because it's on top, but you can pick whichever one you want and it will get you the same thing. So just to summarize these notes from today, we're using elimination and we don't have opposites, so we need to create opposites by multiplying one or both of the equations by a number to create the opposites. So your practice for today is numbers 1 through 4. It's on Google Classroom. So you can go ahead and work on that. And I have the answer key that you can check your answers and then turn it in when you're done.